Hello and welcome to the talk. I'm Chinmay Soman, head of product at StarTree, and then today I'll be talking about how Apache Pinot and StarTree Cloud are building the future of real-time observability. Today I'll begin with what exactly is real-time observability and the different use cases and challenges thereof. We'll take a quick look into Apache Pinot and StarTree Cloud, and then get into the meat of it, discuss in detail the two prominent types of observability use cases before wrapping it up. All right, so let's get into it. Real-time observability is certainly not new. You can see many examples of this around us today. For example, PMs, execs, data scientists often want to be able to monitor the business. This could be in terms of KPI, key performance indicator, or business metrics, insights, reports, and then so on. Engineers, DevOps, SREs want to be able to monitor the different systems and applications. This could be in the form of metrics or logs observability, and so on. And then pretty much everyone wants to be able to detect anomalies or outliers in your incoming data in real time. So if you take a step back and look at all these different types of use cases, the emphasis is on real time. You need to be able to do all of this on data that is fresh and generate insights or alerts that are timely in nature. And the other thing we see here, there are two main subcategories of use cases. The system observability, where you're analyzing different logs, metrics, and traces in real time. And then there's business observability, where you're looking at business events happening through various different channels, and then generating insights and KPIs and oftentimes anomaly detection. So if you distill all these different use cases, we see these common characteristics in the underlying system. As I mentioned, this is all real time, so data has to be fresh. So from the time the event is generated to when we need an insight or alert, it has to be within seconds. The query performance needs to be very high in terms of query latency, which needs to be sub-second. And even though this is an internal analytics use case, oftentimes we need high query concurrency in the order of tens of or hundreds of queries per second. Query complexity, where this defines what you want to do with those queries. Most of the times it's straightforward. You want to do aggregations, group by, order by, but in some cases you also want to do joins and window functions where it increases the complexity. And finally, the data can be very big in these cases. Oftentimes we want to store data which is months or even years old, and this drives up the total volume, oftentimes in terabytes or petabytes. There are many point solutions for solving each of these different kinds of use cases, but we strongly believe you can do all of this on one single technology, which is Apache Pinot. Apache Pinot, for those who haven't heard, it's an open source distributed columnar database that came out of LinkedIn. It allows you to ingest data from various data sources and makes it available for querying in real time for building various kinds of use cases. It is primarily built for user-facing analytics. So the amount of QPS and the latency it supports is very strict. So it's used by, for example, by LinkedIn for all the metrics that you see on the LinkedIn homepage, including who viewed your profile or post analytics. All of those is actually driven by Pinot. And LinkedIn alone, one cluster alone in LinkedIn is driving more than 200,000 queries per second. Similarly, Stripe uses it for generating business metrics in real time, and they use it for various use cases. For example, merchant dashboards, which is customer facing, as well as internal analytics, where they do risk and fraud detection. And then finally, Uber, there's lots of real-time analytical use cases built on top of Pinot, including Restaurant Manager, which is user-facing, and then also things like dynamic pricing and then internal business metrics. They all, as you can see, they're all relying on Pinot for mission-critical use cases, and the scale of data and queries is very, very high. Today, Pinot is a mature technology. It's adopted by various companies across the globe, and we can dissect by the different verticals. So, for example, Walmart and 7-Eleven retail, Citibank, Stripe, VPay in fintech and banking. Logistics is actually very popular. Most of the leading food and logistics companies have adopted Pinot. For example, Uber, DoorDash, and Just Eats, and then so on. And so on and so forth. So we see a very wide adoption across various verticals in the industry. It's also it's a healthy community. The growth has been great so far. Almost close to 5,000 Slack members and 11 million Docker downloads. Let me talk a little bit about StarTree. So StarTree was actually founded by the original creators of Apache Pinot, and the goal was to provide a fully managed cloud offering for Pinot database. So it is cloud native. It's available in all three cloud providers, and then also enterprise ready. And it offers key differentiators on top of Pinot. For example, scalable upserts where you can store billions of primary keys, cloud tiered storage where all the historical data can be offloaded to a cheaper medium like S3, while still giving you high query performance. And then finally, it gives you various applications and utilities for reducing the time to value. So you can focus on building solutions. Today, it lets you ingest data from various sources, as I mentioned, like Kafka or Pulsar, Redpanda on the streaming side, S3, GCS on the batch side, and even things like Snowflake and BigQuery. So you can get data from all these things, and then, of course, query it in real time using an API, but also be able to visualize it using all these tools, such as Superset, Grafana, and Tableau. All right. So now that we have some context on this, let's dive deep into the first category, which is the systems observability. And this is, again, as if you remember, this is where we are analyzing all the metrics and logs and traces in real time. So the classic observability stack for system observability looks something like this. So you have agents at the bottom which scrape the various metrics or logs, send it to the collection system, which aggregates all these things from various destinations, from various sources. Then you have the storage layer for actually storing this data for whatever retention period is desirable, the query layer for querying, and then finally visualization layer. And if you look at the point solutions in the market today, they oftentimes focus on one or more of these layers, but not all. So what this ends up doing is you cannot. It's a lock-in system, right? So when you send your data to these point solutions, you can't leverage the data for other use cases. In addition, you can't really mix and match. If you cannot use your own agent or collection system with some of the vendor provided storage and query. So ultimately, it becomes the system is not very flexible, and the user ends up paying for the cost inefficiencies in some of these layers. And it indeed is a complex problem to solve, right? If you look at the logs metrics and trace, excuse me, if you look at the different events that you need to analyze, there's lots of variations in these different events. For example, the logs need to be granular. You need to look at each individual log for searching. Metrics may or may not be granular. You may have to roll it up. The format of the data could be structured or unstructured. There could be different encoding techniques involved. And then again, various different agents used for collecting these different kinds of events. So it's a very complex ecosystem to deal with. So with StarTree, what we envision is building a disaggregated stack where StarTree Cloud can provide the toughest challenge in this layer, which is the storage and query layer. And then the users can mix and match the other layers on top of StarTree Cloud. So this is a compelling offering because it makes it flexible, right? So you can choose the best in class agents and collection systems with StarTree Cloud, And then it's one platform approach. So once the data is in StarTree Cloud, you can of course use it for observability, but also build other things. For example, powering a real-time application using the same data. And as you'll see later on, this StarTree Cloud offers significant cost benefit for as we can really optimize on the storage part of this layer. So this is how a sample deployment may look like with StarTree Cloud. So you can use something like a Datadog agent or a vector agent on the actual services. Use something like Kafka for as a collection system, which will then get the data into StarTree Cloud. And as I mentioned before, it offers various connectors, for example, Grafana for visualizing these various metrics and logs. And then we also provide specific dialects for some of these events. For example, you can use PromQL for metrics, LogQL for logs, and so on. And the reason we believe this is a compelling offering is the following. Right? So there are three main pillars on which we differentiate against the existing solutions. For example, with Pinot, you're getting the best-in-class storage system in terms of query latency, scalability, and then query concurrency. With tiered storage, a lot of the historical data can be stored in S3, for example. And there are various optimizations that will let you guarantee sub-second or seconds level query performance even on this historical data. Which, with this, it really lets you drive down the cost of hosting all this data for your observability use case. And then finally, StarTree Cloud offers a BYOC, which is bring your own cloud deployment, where the entire stack can be deployed in your cloud account. So it's not only secure and scalable, but this also reduces the network egress cost thereof. So the focus is to really optimize this one layer, give you the best-in-class performance, and then also lower the overall cost of serving. Right. So now let's look at the other one, which is business observability. So this is where we want to look at how your business is doing in real time. Examples could be looking at metrics such as website traffic or sales revenue or stock price. And looking at it in real time is very important. Right? So many times you want to make a decision based on what's happening with your business. For example, if in case of Uber Eats, if the demand is really high but supply is low, you can take an action to balance the marketplace. Or with LinkedIn or other e-commerce businesses, if suddenly your order volume dips, you want to be alerted and then take an action in real time. Having this insight much later on, hours late, is not going to be helpful. So the specific use case that we'll discuss today is for business observability is anomaly detection. Right? So this is really where you look at your key metrics, key business metrics from various sources, and you want to be able to be alerted in real time when something changes. For example, this could be page views drop for LinkedIn, or the number of trips. If it suddenly shoots up or suddenly shoots down for Uber, that would need the team to be alerted and then take an action. And this is, as you can expect, this is very complex. You could of course use traditional tools like Grafana, but they are often limited because the traditional threshold-based alerts don't really work with data that is highly seasonal in nature. So you want a system that can learn the pattern of the data over time and use statistical algorithms to do this kind of anomaly detection. That's where StarTree Third Eye comes in. This is a tool that we offer on top of StarTree Cloud for doing both anomaly detection and root cause analysis. So it'll help you use StarTree Cloud to connect to various data sources, lets you define various kinds of alerts, and once an anomaly is detected, it can also let you dive into why that anomaly happened. So the goal is to reduce the mean time to detection as well as the mean time to resolution for your teams to be very effective. So let me switch to a quick demo where you can see all of this in action. So this is how the StarTree Third Eye landing page looks like. At the high level, you get a dashboard of all the alerts that are active in the system right now, and then various uh, granular view of some of the anomalies that have been detected as well. So let's start with creating a simple alert for now. So you can either do a simple alert or a multi-dimensional alert, where for your one metric, for example, for page views, there may be several dimensions associated with that metric. For example, type of device, geo, timestamp, or the user persona. All of these are different dimensions, and you may want to be alerted on a combination of these dimensions. But for now, let's pick a simple alert. So in this demo, the data set is already in the underlying StarTree Cloud cluster. So we'll just pick one of the existing data sets. For now, let's just pick the page views data. So this is going to simulate any e-commerce website that is trying to detect anomalies with their page views. So if you suddenly page views drop, you want to be alerted on this, or the other way around when it spikes. So the metric I'll pick is views, and then the aggregation function I'll use is the sum. So sum of views over time is what we're interested in. So this is what the data looks like based on the raw data that's stored in StarTree Cloud. Next, what it does is Third Eye will automatically recommend what kind of algorithm will be best fit for this kind of a data. And there are various options to choose from. For example, there is a simple threshold based alerting mechanism, there's mean variance, percentage rule based, and so on. For this, we'll just choose the recommended one, which is StarTree ETS. Uses a regression model and a forecasting algorithm to predict to detect the anomalies. Next is the sensitivity level. Right? So you may want to. This is really where you have to continuously tune the alert, right? So if low sensitivity, it may not detect any alerts in this data. But if I move it to high sensitivity, it may flag some of these data points as anomalies. And then, of course, you can let Third Eye tune the alert for you, which is based on the common pattern of data that we have seen. Then one more thing is it lets you do all this, and if you have to fine tune this yourself, it does let you tune that directly in the JSON format. The other thing Third Eye offers is the various kinds of filters, where you want to ignore certain anomalies, where you know they are not anomalies, right? So this could be, for example, time of the week. You may want to ignore events that happen over a weekend or a specific day, where you know things are already going to be out of order, or even special events. You can use Third Eye to inject things like holiday events, or in some cases, if you know, if you're Uber, if you know there is an event happening, you may want to ignore all of those events for that special event. And then the other thing, the final, once we're almost ready to create the alert. One last thing is to define the alert schedule. How often do you want to run, at what all the days that you want to run the alert in, which you can do it using daytime or a custom cron job. And then also, how do you want to be notified for these alerts? And there's various integrations available today, including email, Slack, PagerDuty, and so on. So for now, this is the final step where you can create an alert. And let me show you an existing alert where it has already detected an anomaly. Right? So once the alert is created, it will notify you using the channel that you've selected on hey, and something went wrong. And you can come back to Third Eye and then do the next part, which is really get into why that anomaly happened. So let's try to investigate this. So this is the anomaly view, which gives you various metrics already in terms of why is this an anomaly. Currently, it has detected that the page views is off by about 45% from the baseline. So let's look at this in more detail. So investigate anomaly. What this does is it drills down into the various dimensions associated with this metric, and then try to figure out what's the root cause of this metric going down. And one cool thing is third eye will automatically suggest a dimension or a set of dimensions which has led to this metric to shoot up or down. In this case, it is already saying all the anomalies have happened wherever browser was Chrome on all the devices and across all geos. So some bad deployment for specifically for Chrome has resulted in the page view decline. So this is the recommended contributors, but you can also do this manually. Third Eye also provides a heat map of the various dimensions associated with that metric. And you can see here, Chrome is the one that has declined. So you can pick Chrome as the dimensions, and then look at what other dimensions we can keep going down across other dimensions. In this case, we know that once you select Chrome, the decline is pretty much consistent across all the other ones. So it's really only this particular dimension that is at fault. So as you can see, once the anomaly happened, we got to the root cause pretty much within a minute or so. If without third eye, you would have to fire various queries at the data set and compare with historical data to come up with the same view, which could take many hours or days in some cases. So third eye really gives you a powerful view into, as I said, reduce the time to detect and time to triage. So let's go back to the presentation. And all of this is actually built on top of Apache Pinot. Right? So when you detect anomalies, it is firing queries against Pinot for doing anomaly detection in real time. So the underlying database has to be very fast, and data has to be fresh. In addition, for the root cause analysis, as we saw, it is doing it is basically doing correlation analysis across various dimensions. So it needs to be able to fire multiple queries with a different combination of group by and get the answer quickly for us to be able to root cause into the issue. So effectively, you want the underlying database, in this case Pinot, data has to be fresh, query latency has to be very low, and it also has to support very high query concurrency. So this combination of StarTree Cloud, Pinot, and Third Eye is actually best fit for solving anomaly detection for business events. And then, of course, business observability is much more than that. You can also build various dashboards in Superset and then generate reports directly on top of StarTree Cloud. So just to wrap it up, as we saw, StarTree Cloud provides one platform for real-time observability. It is flexible. Once the data is in StarTree Cloud, you can actually build various kinds of use cases for both system business observability as well as for real-time applications. You don't have to keep duplicating the data. It is cost efficient. It has various knobs to lower the cost of storing historical data, and the BYOC deployment especially lets you optimize where the stack is deployed. And then finally, it is a query powerhouse. It offers various the indexing techniques, for example, inverted, sorted, text index, geo index, or JSON index. So it lets you accelerate queries on various data formats. And it also provides an intelligent materialized view in the form of a StarTree index. All of these help support very high query concurrency in the order of tens of thousands of queries per second, while still guaranteeing sub-second latency. And finally, you can go try it out for yourself, and the link is right there. Once you register on StarTree Cloud, you do get a free forever workspace. So all of those things that I mentioned, you can actually try it for free. The only limits we put is the QPS and storage quota. And with that, thank you very much for having me as part of this talk series. If you want to learn more, definitely reach out to one of us. Thank you.